Okay, well, thank you very much. And today I'm going to talk about maturation and smoltification. And I hope it's reasonably entertaining. And is that ready? Okay. And I'm from Truro. Used to be Nova Scotia Agriculture College. But we've gone down market a bit, and we're Dalhousie University now. But anyway, what am I going to talk about today? Salmonid biology background. I'm a day-length sort of photoperiod person. That's my background. So photoperiod manipulation can be very useful for producing eggs year-round. These are very important industry tools. Manipulating timing of spawning. Stopping unwanted sexual maturation is it's another way of it's the same problem. How do we stop fish maturing? And there's some photoperiod tricks we can use. And smoltification, Atlantic salmon, rainbow trout, and Arctic char. I've been lucky enough to kind of work with all three fish, and they all get referred to as smolts at when they're going on the truck and they're going to go to seawater. But the difference in smoltification between these species is a multi-million-dollar problem, and fish die when they go to sea. And so we can actually, I'm going to have to ask you questions. So because it's things I don't know, but it might. So you won't snooze off listening to me, because I'm going to ask questions and I'm going to point fingers anyway. So anyway, yeah, I just Melissa said, what about a bit of background? So yeah, I'm from the old country, and student, angry young man around this era. The wilderness years, 1983, and then I ended up at Aston University, and I have to thank Jake Elliott. Some of you may know Jake Elliott. And he talks funny. He talks a bit like Jake. And Jake was with Neil Bromwich. So Neil Bromwich is kind of the godfather of photoperiod manipulation in the UK. He kind of got it all going using day length. And Jake was his PhD student. And Jake left. Jake left to go to private industry, and it left this position. And I kind of, he left me a big freezer full of blood samples, did Jake, and I spent the next 3 years measuring estradiol or something. But anyway, so thanks Jake, and he's a good guy. And so Neil Bromwich, the people we meet along the way is sort of makes life worthwhile, and who influences us. And so Neil, he passed away prematurely, but he was a dynamic. He was a professor, but he was one of these professors that did connect with industry, and I really learned a lot about the disconnect between academia and industry is still a problem. But we have to work hard to try and Neil was kind of a pioneer at that. Anyway, I eventually got washed up on the shores of Canada and ended up in St Andrews, and it was a great time. It was the start of the salmon farming industry. So I was working with Connors Brothers. People I met along the way. Richard Saunders. Pioneer, great fish salmon biologist, and he always referred to a guy called Arnie Suttling, who you know and Robin knew as one of the guys who really got salmon farming. And Robin's nodding his head because I only met him a couple of times.
He started the Newfoundland.
Right.
And probably was one of the key instrumental guys in starting the country.
Dick said he went to Norway, did Arnie, and he came back.
But he did. I don't know about going to Norway.
Yeah, he took a
Yeah, he was my master advisor.
Yeah, right. It's interesting.
Sabbatical leave from DFO, which I think would be impossible now. I went to Norway to learn how they were farming seeds, and then came back.
And then there's a technical report published in 1981, I think, and it was the Deer Island trials there, and Arnie was the main man. But I think Richard Saunders helped get the money, you know, to get. Anyway, great guy. And I met then at Connors Brothers, I don't know if Chris Francie was sort of a larger-than-life character, and I'd never met anyone quite like him. And Bill Robertson, who I met in January, he's still working with ocean trout. And Bill, we used to play on the St Andrews soccer team together, and it was always good having Bill on the team because he was a black belt karate guy. And sometimes we had to go over to play Woodland in Maine, and the roughest bunch of guys, you know, you put shin pads on the back of your legs and on the front. Anyway, as long as Bill was in the team, we were all right because he could, and he was nice. Anyhow, Brian Glebe's I call him like Mr. Arctic Char, but he's pushed Arctic. But it was great to meet these people, and Paul Harmon, who worked with Dick, and Dick Peterson. I was a great sense. I always remember the people with a good sense of humor, but Dick Peterson was a great guy and very good salmon physiologist. And Tillman, you worked with him, and Debbie Martin. This is rubbish. What's he talking about? He's just name dropping all the time. But anyway, it's a bit different, isn't it? Anyway. So I ended up in Truro in 1995, Nova Scotia Agriculture College. Big influences. Bill Stone is an old guy who fishes on the river, Shubenacadie. He's a very dear man. I got obsessed by striped bass and students, exclamation mark. That's filled my life. And I sometimes do foolish things, sort of trying to lecture, because I know when I'm, you know, those 9 a.m. lectures and nobody's listening to you and they're all on their phones, and sometimes I just do something, and so I'm turning into sort of the mad professor or whatever, just to kind of it's the students' fault, because they don't. But anyway, I'm just and now who's this? I just wanted to put this up for and you know. It's young Jim, 1970, but very early in life, that's when we know that we're a fish person. And I've always been happy by the water, monkeying around, trying to catch fish. And that's the River Thames, actually, near Oxford, the headwaters. Anyway, that was skinny little oik. Anyway. And, this is Bill Stone. I just wanted to, he had a stroke around Christmas time, but he's a boat builder, he's a fisherman, and he knew the Shubenacadie River like the back of his hand, and it's a really crazy river with a tidal bar, and I really greatly admired that man. Anyway, so on to the subject material, a bit about day length, and of course we have it's a great time of year. It's the days are getting longer, and it would be intolerable if I lived on the equator with no real day length cycle. We're about 45 degrees north, and the days are getting longer. And I've never been to Norway, but the extremely long day length there in summertime. And it must be miserable in Norway in December. It's dark all the time, and anyway. But so this annual day length cycle. And then we have the March equinox, and the longest day is June 21st, and September 21st is when the days are getting less than 12 hours. So this beautiful and life on Earth has evolved and adapted to this as we know, and it's all thanks to the fact that there's a 23-degree tilt in the angle of the Earth. If it wasn't for that, we wouldn't have a day length cycle. It must have been the big guy in the sky. Like, I'll just tweak it over a bit, because the folks down there will enjoy a bit of summertime. Anyway, I don't know why there's a 23-degree angle. But, does anyone know the answer to that? I don't know. Anyway, Thank God for 23 degrees. Now, so photoperiod's important, but it's photoperiod and temperature, those two extremely important factors. And I've got here, stepping on the gas, temperature controls metabolic rate of our fish. And it was Professor Fred Fry, I think, in the 1950s, another very famous Canadian, he described temperature as a controlling factor. And it is a bit like the gas pedal when you're growing cold-blooded animals like fish. And this is the animals, this is air temperature, but as we know, it's, the water gets warm in the summer and it cools down in the winter. If we're growing, but increasingly we have fish in recirculation systems and we can control temperature, so we can control the gas pedal, as it were. So that's, so temperature is hugely important. This is, and it dictates how fast fish are going to grow. So of course, we're extremely interested in that. This is an old paper, Jeff Power, thinking about smolts. And this is the wild habitat. So here's the most northerly populations of Atlantic salmon. I think this Leaf River, somewhere up here. It takes the fish many years to reach that certain size when they become smolts, maybe like 5 years. And very short growing season, maybe just 40 days up in northern Labrador. So, you know, water temperature is the key factor controlling growth. As you come further south, the growing season gets longer. And for example, Quebec North Shore smolts in the wild can maybe reach smolt size in about 3 years. There's a reasonable growing season. So I just wanted to emphasize that, you know, temperature is important, and we need to know the optimum temperature for our fish. And if we can control temperature, or we put our fish farms where the annual temperature cycle is going to help them grow quicker. So, I mean, that's what we do. And so in Newfoundland, does it take? It must take longer to grow. Can you tell us? How much longer does it take? Probably 30% longer. 30% longer. And I always, when I was in New Brunswick, I was always when to transfer smolts to seawater, and it was like, wait till the seawater gets above like 4 or 5 centigrade, and it's later. It must be. Is it later in Newfoundland? It's June. So do you have to sort of photo manipulate the smolts to smolt later? Yeah. You do. So you delay smolting. See, I'm learning a lot today. I didn't know that, but I was sort of, they must, because it's dangerous. You put them out in June. Yeah. Yeah, no, it would ordinarily be a disaster on the regime we have in New Brunswick and Nova Scotia. Right. Through the sulfification of the air. Right. And is the seawater temperature, is it still that sort of wait till she gets to 5, have you got a magic number? 4 degrees is your magic number. Oh, that's interesting. I'll get that for next. But this is I'm interested. I'm interested in striped bass. But another thing that's important is the ontogenetic change in the optimum temperature for growth. So whether it's striped bass or rainbow trout or any as fish get bigger, their optimum temperature for growth goes down. And for example, small striped bass don't grow at 16 centigrade. That's what's going on here. But big striped bass at 16 centigrade grow really quite well. So whatever fish you're growing, if you know the optimum temperature, it's like a moving target. And so that's another sort of, and do you know that for Atlantic I mean, I can't go to a scientific paper and see how the optimum temperature for salmon changes, but you must know that.
Yeah, no, we do.
You've got it all. But it's quite it's a complicated move, and
It all depends on the life cycle, the time of year,
right.
and everything. But yeah.
So there's a lot of unanswered questions about the ontogenetic changes in the optimum temperatures, and there's still a lot of work to be done. Yeah, so that was decision periods. We think a lot about decision periods. So I'm looking at Chi here. He does all the clever stuff with the graphics. But here's a light cycle here over several years, and we have fish starting feeding here. There's periods of time during the year when they're going to have to make a decision. Are they going to, say, commence sexual maturation or not? Decision periods occur many months before the completion of the event. So here we're thinking about Arctic char, for example, that we're going to have very high sexual maturation rates in the fall of this particular year when they're 2-year-old. 80% of Arctic char can mature, and it's always been a real killer. It's put people out of business. But what we need to understand is when do the animals actually make the physiological decision to commence sexual maturation? And it is many, many months before the completion of maturation. And we don't have, or I don't have a very good handle, but we need to understand this, and we need to stop. We need to be able to manipulate this decision to stop fish from maturing. And it's important. So maturation and smolting take many months to complete. Fish need to know, yes, these processes take many months. So through evolution, fish have synchronized their life cycle to they've used photoperiod cycle as the Germans call it a Zeitgeber, but they've entrained their physiology to the light cycle. So these decision periods are defined by the photoperiod cycle. And any time from probably first feeding onwards, if you are switching the lights on or switching the lights off, this can have consequences further down the road as to whether the fish are going to mature or not. And it's extremely important to consider the photoperiod history of the animal from day one. And when fish are getting moved from one hatchery to another, there's probably opportunities for uncertainty as to what the photoperiod is. Anyway, that was a point I wanted to make there. So yeah, that's my photoperiod history is important. Huge letters, and it's just what I just said basically. But it's I think almost with the ACFR or every batch of fish, you need to know what was their photoperiod, everything. I think it's very important. Anyhow, that's a bit of background. How are we doing? Not too bad. This was, so eggs year-round, manipulating the timing of spawning. This is from one of Neil Bromage's papers I just kind of, but there's all kinds of advantages to getting more than one supply of eggs a year. And I think Cook have 3 spawnings a year, Jeff?
I think so. We chilled down and slowed down.
Ah. And but that gives you, using your facilities, and Scotian halibut had photoperiod manipulation. How many spawnings? You had 3. So, and I know in Iceland, stonefisker, they produce several batches of eggs a year. I think they're all female, and so it's an important tool to stabilize, to have eggs year round. Bit of history. Hoover and Hubbard, 1937. This is the first paper that was ever published showing that you could manipulate the timing of spawning of fish. and it was done in New Hampshire on brook trout. And this was the lighting. Now, they didn't have to take the light right up here, but they advanced the timing of spawning of these brook trout by several months. And this was pretty groundbreaking stuff in the 1930s. It followed on the heels of William Rowan in the 1920s. And this guy was working with birds in Manitoba or in Canada, but it was the first evidence that, you know, birds synchronized their breeding cycles to photoperiod. So this was hard on the heels of that. But it took many years, many decades really, for photoperiod manipulation to be used in aquaculture. And so I've put old Neil up here, Bromwich, Porter, and Randall. They went to, when I was with them, we were in Birmingham, but they ended up in Stirling. But it was Bromwich that really got photoperiod manipulation on the map. And Jake was working on trout farms in south of England to get spawning at different times of the year. And Jake always mentioned another guy. He mentioned Colin Whitehead, who really did a lot of. Jake had always great things to say. I only met Colin once, but these guys were on the ground doing the work, photoperiod manipulation. Neil was on the phone all the time trying to get the funding, which is, I don't know what's more difficult, getting the money or actually working with the fish. But they both can be very frustrating and complicated. So I've mentioned Jake Elliott a couple of times. He's quite good on YouTube, actually. And there's a few, so that's the Oak Bay facility. And he's like, "Hey up, how you doing? I'm Jake Elliott." And I talk a bit like that Jim guy, because we're both from Yorkshire, you know, crude northerners, and he's very funny, but he can be extremely crude at times. But I think that's an endearing, it gets your attention. And I'm a bit like that sometimes. Only in the van now, when we're in the vaults, like. Anyway, so that's Jake, and so manipulating timing of spawning. This on the right here, this is a very fuzzy photograph from Scotian halibut, but we took our students there, and the broodstock were in. It's relatively easy to. You need a light-proof tank. You can do it with tarps, and it looks quite crude. The hard part is manipulating temperature. Because if you want your fish to spawn in August, you might have to chill your water down by 10 degrees centigrade, and that might cost you an arm and a leg. The photoperiod manipulation is quite easy, though. So you need to control both photoperiod and temperature, and then they need to be in synchrony. Anyway, it's like these guys. He's just cut and paste those boring lectures we had from that. Can he come up with anything more original? Anyway, it was just halibut, but it was a good example, and I think you maybe copied the Icelanders. And I really don't like that, where like it was great to hear Tillman saying, like, thank God that sometimes the Canadians do something and then it's like the Norwegians are sort of behind us. So often it's the other way around. And I just like, oh, still claim to do it first. How do they? And then they, what? Oh, it's like, what's the strategy for Canadian aquaculture R&D? What is the strategy? It's like, oh, let's go on a field trip to Norway, see what they're doing, and then bring it back here. But anyway, this looks rather confusing, but basically it created 3 batches of spawning fish a year by the mid-90s. So here they're all spawning in March or whatever, but by photoperiod manipulation and temperature manipulation, we have eggs in December, April, and August. And basically the trick, it's not really a trick, but it's just a 12-month photoperiod cycle that is sort of out of phase with the normal photoperiod. And it goes up to 24 hours light here because it's in Iceland. But that's sort of the standard procedure, and I'm sure at Oak Bay there's a 12-month photo period cycle that is the shortest day will be in August or something like that. So, but we have to thank Bromwich and Colin Whitehead and Jake Elliott, who they kind of got all this started back in the old country, and it took a while to come to North America. Anyway. So that's that. Stopping unwanted sexual maturation. You got to stop me. How are we doing? All right. 10 minutes. Anyway, this. So by the mid 1980s, we were getting quite confident. I was like, oh yes, we can manipulate the timing of spawning of rainbow trout, and Neil Bromwich sent me off to this farm in the West Country. And it was ex-wing commander Brian Burks who owned the trout farm. Because in England, it's very, the upper classes, they either go into finance or they go in, or the not so intelligent ones run a trout farm. It seems like a very respectable thing to do. And Brian Burks, he had this classic kind of handlebar mustache. And he's, oh, hello Jim, how are you doing today? And bravo. Well, well, yeah, we're going to do some photo period manipulation, and when would you like your eggs? Eggs in August would be marvelous. And we were like, yeah, okay, we can do that. And we've got some funky new photo period regimes. We don't need this. We got these square wave ones. Oh, jolly good, jolly good. Well, see you in August then. And anyhow, August came, and most of the fish were sexually immature. And Brian was like, oh, I thought we were going to get 100,000 eggs from these all-female rainbow trout. And well, I said, well, for some reason, Brian, most of them haven't matured. They're sexually immature. And he's like, oh dear. What are we going to do now? Well, I think that was like the last experiment we ever did at that farm. But what we'd stumbled across was a way of using photo period to stop sexual maturation. So the greatest discoveries are always totally accidental. And anyhow, that was another example of that. So, but all the sea cages of the northern hemisphere are now glowing with lights in winter. And did you tell me, was it October? What's your October to?
It's October till around the 15th of April.
15th of April, not the 16th. There's some magic in it, isn't there? And but it's a, and here's and Taranger is that Taranger's he's sort of the high priest of Norwegian photo period, hocus pocus, and. But anyway, it's a standard procedure now in the sea cage farming industry to prevent grilsing or reduce grilsing. And this was a paper in 2007, but it's a multi-million-dollar problem if you've got a lot of fish maturing. And on the right here, we have Arctic char, which has been cheese. We've got our fish from Shippagan over the last few years. Brutal percent maturation under normal photo period regimes, but we've been able to cut that down to less than 10% maturity. Timing is critical. Timing is critical. And so this is, well, this is from Tarrant. Thanks for this one, Chi. But again, we're back to this light cycle idea and the fact that as we know, salmonids are going to mature in the fall, November time. That's when they're normally sexually mature. The decision period is this the previous winter. And so here's a bunch of fish going on to 24-hour light, and then they stay on 24-hour light. Now, this is from Norway. Maybe that's June 21st. If it's Jeff's farms, it's like April 16th, which is somewhere here. And we've been doing the same thing with Arctic char in tanks in our lab. What is the optimum timing? And what And the mechanism by which photoperiod is stopping maturation isn't well known. The scientific literature is still full of speculation. And so and I think we've got a little bit closer, Chi, haven't we? But it is complicated. And so that's our goal, to try and understand this mechanism. And so these are the types of experiments we've done. So we're kind of making the assumption that a char and a rainbow trout and an Atlantic salmon have the same fundamental mechanism for controlling sexual maturation. But we might be wrong. Char might have a slightly different chronology than salmon. But in the scientific literature, everyone's like, oh, the salmonids are probably all the same. But that's probably wrong. But anyway, we're using char as a model to try and understand. So these are the types of experiments Chi's been, here's your 80%, 77% maturation under a normal day length cycle. This is 24-hour light. LL is 24-hour light for different periods of time during the winter. And we can see stepwise changes in the percent maturation. This is males and females combined. So these are the kind of things we've been doing. And everyone knows that 24-hour light is a useful tool to stop sexual maturation. We think it's getting abused. So it's like, if 24-hour light in winter is good, then more has to be better. We'll just put them on 24-hour light from day one. That's got to be good, right? And people at farms have done this. So more is better, and so Chi's experiment, more is better. Let's leave them on 24-hour light from first feeding onwards. Let's leave them on 24-hour light for a certain first feeding, and then they maybe go into natural day length for a while, and then they go on 24-hour light in winter. These are probably scenarios that happen on fish farms. They're on, first feeding, 24-hour light. Yeah, great. Oh, now we've got to move them out, and they go on to some other weird photoperiod. And then they go to the sea cage site, and then Jeff puts them on 24-hour light from October to April 15th. And someone else, but the percent maturity might change from year to year. And he's nodding his head, and I'm glad, because it's not consistent. Is that correct? Percent mature, is there variability? Yeah.
Traditionally, we have 10 to 15% maturity without light. And it all depends on the year class and whatnot. But,
right.
We're getting below 1.
Oh, brilliant. Oh, that's great. I didn't know that. Yeah. Less than 1. Oh, that's good.
That's partly due to our breeding program.
And so but that's interesting. So that's great. But this is an example. There's a lot of interest in growing salmon in land-based facilities. So it's kind of the sexy kind of thing right now, and there's maybe quite a lot of funding for it. But there's this Freshwater Institute down in the US, Good et al. Have come up with quite a few papers. And it seems like they're getting some horrific percent maturity issues in these land-based operations. And just reading the literature, it seems like they're groping in the dark in terms of what is the optimum photoperiod regime. And so the things we're doing maybe can help the land-based guys. But early match, because to make any money, they have to get the fish growing really quickly. So they keep them at 14 centigrade all the time. And so the foot's, you got your foot on the gas big time. And fish that are growing fast are going to mature early. And that's putting land-based salmon operators probably out of business. It's a huge problem. Anyway, that was that. So that's it. Should I shut up? Quite blunt. Oh, they've probably had enough of me by now. But smoltification, I've only got, here's the old standby, first feeding in February, under a natural photoperiod regimes, salmon undergo this interesting, we called it bimodality. It was kind of discovered in the 1980s. Some fish become relatively fast growing. This is Atlantic salmon. Some fish remain relatively slow growing. This was Connor's Brothers Lake Utopia hatchery with surface water. A proportion of your fish would become 1+ smolts, but maybe in the late 80s, maybe 40% didn't get big enough to become smolts. But that was and then we were waiting for 4 centigrade to come, and then the fish were off to Beaver Harbor and into seawater. So that was the old days. The old days look like this. This is from Scott Jeffrey, who used to work at Crooked Creek, and you spent all December shoveling out snow from around those outdoor tanks, and that was good. Nowadays, everyone's inside, sort of sitting around the stove. I think this is Stephenville hatchery. It's all recirc. You can control temperature and photoperiod to whatever suits this year's recipe, and so that's today. Yeah, the old days there was no growth in winter, but these new facilities are probably changing. So we're thinking about the photoperiod history and the growth history of our fish. These new hatcheries can manipulate whatever they want, and I'm sure there's quite a bit of experimenting going on, like what is the optimum regime. Anyway, that's that. There's the water heater. Yeah, you can control water temperature. That's anyway. You can tell I was getting out. Oh, geez, what am I gonna? I think I'm done. Oh, and now, yeah, right. So I'd forgotten this, but there was a lot of push for 0+ smolts in the 1990s. Could we produce smolts in October? And this was one of the first papers that proved you could do that. There was me and good old Richard Saunders. Terrible. We produced smolts in October. We put them out into cages in Beaver Harbor, and they all kind of died over winter because it was like 1 centigrade. Not a great idea. But on the west coast, in British Columbia, where the seawater temperatures are warmer over winter, producing under-yearling smolts is standard practice, I believe, and it works very well. So S0 smolts. But I think in Newfoundland, you're producing like huge 1+ smolts.
We're working on it. We're going to work on it in Canada as well.
So, delaying smolting.
Delaying it would be a large RAS system with salt water, and we put the fish in at like 100 grams and grow them in the RAS system until you got 300, 400, 500 grams or bigger. So with that, we need to determine how do we manage the photoperiod for smoltification on those big fish, because we don't want them to smoltify when they're 100 grams. We want them to smoltify when they're much bigger. So.
Right. And if you need, I mean, if you need any help, or if I can help in it, I'd be delighted to, because it's complicated, and that's all I know. But this is the last slide. Degrees of smoltification. I know Sherman, and yeah, we've talked about getting trout into seawater off Pubnico, and what is the optimum? They don't smolt like Atlantic salmon. They don't. But if we can acclimate them to brackish water. But personally, I've never done much research on this. I really, but it's a huge issue getting juvenile rainbow trout into seawater safely and getting them growing. I think it seems to be going better in Newfoundland, where the salinity is lower. But when they're on the truck, oh yeah, we got some rainbow trout smolts, we got some, but they're quite different. They're very different. And we've spent quite a bit of time, all right, do Arctic char show any pre-adaptation to seawater? And I would say absolutely no. And anyone who's put Arctic char into sea cages has probably lost them because of our ignorance of their salinity tolerance and again, just basic biology. So anyway, that's probably all I got.
We want to take maybe one question.
So thank you very much. So I hope that was reasonably entertaining.